Okay, thank you all to be here, and let's start a bit. First of all, I want to say that this is not a general overview of Celery, how it works. It's not a generic overview of the whole library, but we are going to explain some little tricks or some little extension that maybe you need while you're working with Celery. Then I will give you just an introduction to Celery and Django-Celery, and then go forward some specific task and extension. Okay, just a bit about me, because I'm unknown. I'm a web developer, and basically I love work with Python, but you know, when you're working for a company, you can't always work with the same language. There is some production needs, and then I'm working with PHP for front end, and Java, Android, JavaScript. I'm a little Celery contributor, very little, just few line of code, one of the hundreds, of course. And about Jamendo, the company where I'm working for. Jamendo is basically a community of free music. We are not buying a license of very no music. We just allow artists to upload their music and share with users through the Creative Commons license. Of course, Creative Commons means free for the user, but it's not free for companies or just who want to use it for advertising or marketing. They have to pay for license anyway. Then what we do basically is give free music. You can download all your music from Jamendo. You can listen to it. But if you have a company, you have to pay a cheap price, of course, because it's not you are not buying songs of big artists like Madonna. But maybe it's good music too. And then we share the revenue with the artist, 50 and 50%. 50% to Jamendo and 50% to the artist. In this way, we create also a different market for company that want to buy, or maybe also for little private that want to do things in the right way, but without spend a lot of money. Of course, Jamendo, as a big community, is obviously needs a lot of background work, especially because it's basically a music website. This means that every artist have to upload in high quality format, then we have to encode it in different one, and we have to make happy artists by show them how many listen you have, how many download, and you are first in the chart, and your tags, the best tags, and stuff like that. And of course, sometimes we have also some need. Thanks. It works. Great. I have to start again. Okay. Okay, I was saying that, okay, I didn't remember anymore. Maybe it was a complete concept. Simple task, the first task that we want to write with Celery. Okay, this is my favorite task. Mainly, is my objective. And you can write it with decorators. You can also import the task-based class and simply use extend the task class of Celery. This is an example with decorator. And this is make money, of course, how much. And you can easily understand what the tasks do. This is an example by a Python shell of how to schedule the task. The methods delay say simply schedule the task, send a message to the broker, basically. This means that I can have 5 Celery workers on 5 servers. On one of these, I'm just going to call the method delay with the right args, in this case, $200. And after the results get, is waiting for result. Until the results are not ready, he didn't give you back any output. Sometimes people are a bit confusing because it seems that you are simply running the task on the worker when you have the shell open, but this is not true. The worker is a producer, send a message to the broker. Maybe is him that get back the message again for execute it if he's the only worker in the whole cloud, but can be also executed for other workers that are actually listening to the broker, to the queue that you define. Okay, until here it's quite simple. A great thing of Celery that you can write in task. Now, go to make money in the real life. We have a new parameter. I don't know, I have it. I don't know if you have it. It's wife. Default is true for me. And this is basically what happened the first time that you execute the task. You have an exception. You can't make money if you have a wife. Then, what happened? Okay, this is true now, but it's not true in the real life. You can come back and put the wife at false. And basically is what you see. If there is an exception in this block of code, you recall the same task with the retry method. The exception, the countdown means from now, how many seconds I have to wait for retry the task again, and the args. The second args is set to false. This means that after 6 seconds, this task run again with wife at false, and you can earn your money. Maybe you are not enough for Bora Bora, but anyway, it's a little step. Why passing also the exception to the retry method? Because Celery by default have also a retry max retries parameter. This means that a task can retry maximum 30 times. What happens if this task run 30 times, always with an exception? That the exception that you're passing in the retry method is raised. And in this way, you can understand and you can read your exception and see what is going on. The countdown, of course, is very useful because if you imagine an example that you have to work with external API or services that sometimes are down or they are not responding, in this way, you can try after a bit of a time, or maybe you can also retry the task with an incremental retry. You can increment all the time of the 50%. You can do what you want, basically. This is a bit more complex. It's task set. This means that I'm going to launch several tasks within another task. I just define a task set, as you can see here. This is basically a real task or an extraction or a real task that simply have to get 2,000 track and split it in slice of 1,000 and create an XML file of each 1,000 of this track. Of course, I don't want to do it in a big task because if something go wrong, I have to start to rebuild again some files, or maybe I have to re-upload again some files. And also it's a bit difficult to understand which task is giving you the problem or which track is not fetchable. The basic solution is, as I can split 200,000 songs of slice of 1,000, I can also run 1,000 tasks that are going to do this job on only 1,000 songs. And this is basically what the task sets do. You just define a set of tasks by passing them the subtask parameter, as you can see. You define a list of tasks, and for each slice, in my case, slice is just a list of IDs. Each slice contains 1,000 songs, and you append to this list of tasks a subtask of Celery. Upload track slice is the single task that did the job, that upload some track information on an FTP. And subtask and the args that you want to pass to your subtask. In this case, my slice, my 1,000 IDs. After, you define your task set with a list that we just created, and you call the method apply asynchronous. This means that from now, you can use a method that is called task result ready for wait for the result. Of course, if you put a while cycle here on results ready, this task will run until all the other subtasks are not finished. What does it mean? This that if you have a concurrency if you have a concurrency option on your worker, my worker can run only 3 tasks per time, and you wait for all your results inside another task. This means that you have, we can say, one place busy by this task that is just waiting results, and this is not good because you can run only 2 tasks on this worker for probably some hours, because potentially you can run a lot of tasks. And then the cool things that you can retrieve this task for just check the results. And you can do it in this way. I don't want to go so much deep in it because it's very specific, and I just want to explain you the potential of retrieve the task, let free the worker to execute other tasks, and come back after 1 hour just to check if the results are ready from all your subtasks. And when the results are ready and all the results are successful, you can do something else after 5, after 6 hours, after 7 hours. Or you can also say, as you can see, some of the task was failing. And you can also better understand what is going wrong, because you have each one of these subtasks in your monitoring tool are Celery tasks scheduled in the right way, like as a normal task. Then you can have better debug, and you can also rerun your single slice if something goes bad. Okay, this is the Jamento task class. Of course, I don't want to explain you how we write our code. It's just for let you understand what you can do by override some common methods of the Celery task-based class. The most important thing, the most important methods, I think, are the call and the after return. In the main task class of Celery, these methods are called at the start and at the end of each task. In this way, you have an entry point and exit point, and if you need to implement some common behavior to all your tasks of your system, you can. I don't know, for now was simply create a temporary folder and free it when the task finish. If you need simply an atomic area where the task can write, you can create a temporary folder with the ID of the task, and when the task is finished, you can clean it. And you can do basically what you want. You can also define some common option to your task, the max rate risk parameters. And if you extend your class, and not anymore the Celery task-based class, you can have your personalized task. Of course, it depends what you want to do. And this is, I think, the two important things because through this, you can really implement your personal behavior. You can extend it. And also, for us, is more easy because new developer that is going to write new task, they don't have to care about this behavior. They have just to write the single task and don't care about what is going on if the temporary folder is deleted or if we are going to finish our space on the disk. Basically, what you can do, you can also have web monitoring tools for your Celery system. You can monitoring your tasks through a web interface. This is 3 common projects. Of course, I'm going to speak about Django-Celery. And what is Django-Celery? It's just an extension for let you monitoring the task through the Django web admin and also for schedule it. I said before that you can define your periodic task, your cron, in a config file or in a database. If you are using the Django-Celery with a MySQL database, in this case, you can schedule your periodic task through a MySQL table, through your Django admin interface. You can simply do add periodic task, run every day. This is the task, OK. And you schedule it your task without open any config file and without writing it anything. Basically, another important thing of Celery, that Celery have to know the task that you have to run. These tasks have to be registered. This means that you have to say to Celery, where are your tasks? And with Django-Celery, this is done through the installed apps of Django. You create a package. You create a task spy inside this file. You import your task inside this file, or you write your task inside this file. And through installed app, Celery is going to register these tasks. This is basically the difference when you are running through Django-Celery. Celery, of course, you have to launch it through the manage py of your Django project because the settings is going to replace the basic Celery conf file. This means that all you write in your Celery conf file have to be written in the settings of your Django project too. This is just a few lines. It's what you need for run Django-Celery on Django. You just have to add to the installed apps Django-Celery, call the setup loader, and Celery bit scheduler. Here you say to Celery, you have to get the periodic task that have to be executed from the database of Django. You can also have different scheduler, the config file. In this case, you are saying explicit to use the Django ORM. And of course, after you have to specify the broker settings where I have to connect to fetch the message and all the standard stuff. This is a schema. It's a schema when you are using Django-Celery, and not only Celery. As you can see, you have a Celery cam that is basically a camera that takes snapshot of the states of the tasks every 5 seconds, every 10 seconds. You can also write your personal class and store these results in a table of the Django backend. In our case, is a MySQL. And you can simply access to the Django admin and see task state and see the list of all your tasks and the state, if it's running or if it's started, or if something go bad. And as you can see, the worker in bit mode is checking which scheduled task we have on the Django backend too. This is an example, or you can see how looks Django-Celery. You have your cron tabs intervals, your periodic tasks that can be intervals or cron tabs, and your task state, where you can see all the list of your tasks, and also your workers. Through the interface of workers, you can send signals for kill it or restart it. This is the task state table. The Celery cam takes snapshot, throw given from the worker, and store the status on this table. It's a temporary table, of course. Every day, normally there is a Celery task that clean this table because it's just such as real-time monitoring tool where you can see all your tasks. You can also go inside, see the details, if there is an exception, which exception is, and stuff like that. Now, here you have the monitoring. You can schedule a periodic task. If I want to run a task manually, I say, okay, I want to launch a new task that is not scheduled yet. Okay, you have to use a shell. You have to log in on a machine, or you have to call the delay method by manually. Then this is just simple things. We just add a little extension. It's just 10 minutes because you just have to call the delay method through a Django view. And in this way, you are able to run one of the registered tasks on your system by the web interface. This means that you can run it from your phone or from everywhere. Maybe it's not the best things of this world, but sometimes it's useful when you are on the beach and the boss call you and say, the tags are not up to date. What we have to do now? You don't have to come back home. You can schedule the task directly from your phone. Another thing is from the task state table. If a task fails and I want to rerun it manually with the same args, like the same way, we just have a little button for rerun the task again with the same args. And this is just a facilities for don't lose so much time when you want to rerun a task or just test a new task on the production environment. Another things that our environment needs is unique tasks. Okay, you have the rate limit, basically, in Celery. You can say you can run for now until 10 minutes. These tasks have to be the only one of this type that have to run on the system. But it's just something specific and can be done on the task type. What we was needing also is a unique task, but also args. An example, I have a task that upload albums or recalculate stats about a single album. Then the args is an album ID. Maybe I don't want that two tasks that calculate the stats of an album have to run at the same time on the same album, but they can run on different albums. Then we just define a list of the settings for, say, you have to be unique on your arguments. This means that you can calculate stats of two different albums at the same time, but not of the same album, because they are going to use some common resources, and you can have wrong numbers of your stats or other problems. Okay, our solution maybe is not the best. We use a MongoDB for write and release logs. And as I explained before, through the call and after return method, you can also do these things. You can check if there is a logs, and you can then retrieve the task if there is a log, or simply throw out it. Best solution can be a cache, a virtual file system. Basically, I'm not the one that have to say that. We will see. This is an example of how we define our unique tasks. Okay, maybe it's not the best way. You can imagine if you have a lot of tasks in your settings, the unique tasks variable will be very big. And we also say what they have to do if there is a lock. Because probably if there is a lock, you want to reschedule the task again. Or probably you don't care. You can also throw out it. You can also keep it, leave it fail because you don't care. And then you have a lock on type. There is some tasks that can run with different arguments and some tasks that don't have to run, also if they have different arguments. This is, of course, a special case, is our case study. But maybe a unique task, I think, is something that can be useful to a lot of people. And, okay, this is a little code that is just check if there is a lock on start, and if there is, can retrieve the task or fail it. And, of course, when the task finish, the lock is released. As you can see, if your server go down, if your process is killed without calling the after return method, you have still your logs that is in the MongoDB. This is not so good. Maybe will be nice to add an expiration for how to expire the logs. We'll see in the future. And another thing, sorry, the computer is going along now. Okay. Okay. Another problem of Celery is the logging. Basically, when you have a lot of workers that are running on different servers, maybe sometimes you need a centralized logging. You want to read the logs in only one place, or maybe you want also to filter it because you don't want, sometimes when you execute a task, you don't know exactly on which worker will be executed on which machine. But with Celery, the logger is a bit difficult because you have different loggers. The same handler for Celery is added to different loggers. When Celery do log some file, is the same handler, file handler added to different object. What does it mean? That if you get the main logger, the Celery one, you will have back only the main process logs and not all logs from all pull worker or from all tasks. Then extend logging was a bit tricky because was just signals for override the whole logging procedure of Celery. And then you will lose also the log on file and you have to rewrite it or just look at the source code and reproduce it. But after the last version, it's just my little contribution. You can get back your logger after it's set up it. And then you can add your handler and you can extend it without rewrite anything. Of course, in Celery, basically you have as you see before, three main loggers, basically. The single logger of the task, the logger of the main process, and the logger of the single pull worker. This is actually what you have to do a centralized logging with Celery. You just have to import the signals and connect to these signals. In this way, every time a logger is set up, you can get it back and adding a new handler, like Celery do. In our case, we are using a syslog server. Then we add an handler for the syslog server. We specify the same format of Celery, specify a new level, and we simply add the handler. And this is all you need for a centralized logging, actually, with Celery. And that's basically all.
Questions? Is there any way to interact with tasks while they're running? I mean, can the tasks be configured to stop and wait for events to happen, like, for example, a signal from a user or something else?
Celery supports also event library inside the task. Then you can also use this for wait for something. Then we use G-event and eventlet too. I think G-event is the main one, and eventlet is the backup one. Direct interaction, you mean, with signal? Yeah. Yeah, you can interact with tasks. Basically, you can rate limit it, you can kill it or revoke it. If the task is scheduled but is not executing, you can select the task row, choose on the option menu, revoke the task, and the task is revoked from the queue, or can be also killed while it's running on the worker. No, actually, there is also rate limit, but it's just for say this task don't have to run in the next 15 minutes again, not others.
So my question is, how much setup do you need on development machines to use Celery? Can it run in process, or do you need separate servers and so on?
Basically, it depends what you have to do with your worker. I mean, the setup for Celery, it's quite basic. You need the library, and there is not so much dependencies, sorry. And you can also run it on a machine that are doing different things, that maybe they offer different service. Of course, it depends on how many load your Celery worker create. I don't know if it's your question. Maybe try to explain better.
Let me try to rephrase it. I was referring to developer machines, that is, say, developers' personal laptops. Do they need to set up any, I don't know, AQMP or whatever it's called, servers to be able to run the application on their own laptop? Or can it automatically start up in the background, maybe run in process without a separate scheduler or something?
You mean the broker? Everything. Can be set up to start up alone when you restart the machine and all this stuff, you mean? Because, no, sorry, but it's just because what I can say that we have an environment that basically is done everything alone. If the machine go down, you can do whatever you want with your broker or with your worker. You can restart it, and you can restart your monitoring tool. And
so basically, for developer, it's as easy as running run server on Django. You install if you have a Ubuntu or something, apt-get install RabbitMQ. Now you have broker. You run bin, so manage by Celery D. Now you have a default worker. So yeah, you need a couple of terminal windows, but that's like each worker has one terminal window, and there's your Django run server, and that's it. It's like 5 minutes of work, trivial stuff.
Just also for specify that you don't need Django or run Celery with manage Pi on each of your workers. This is because if your workers is only a consumer of task and it is not running in bit mode, he don't need to run with manage Pi. He can also run without the Django admin, the Django-Celery extension, because the Django-Celery extension allows you to schedule tasks through the interface and to just check the results. But this is done just by a little process called Celery Cam that you run with Python managed Celery Cam. This means that you can have 10 workers and just one that is running with Django-Celery. The other one just standard Celery also.
So we are running since a few months Celery with Kombu as backend. And we are facing like a couple of problems, so maybe you can comment on that. First of all, the storage, the backend itself. As I understood, you're using MongoDB for results, right?
It's not specifically specified in this line, but we are using it actually.
Okay, so it's for results and as the broker backend, right? So for both things.
No, the message package is done by RabbitMQ.
Okay. Okay.
Why? Because if you use the RabbitMQ, Celery creates a new queue for each on broker on RabbitMQ for each task. This means that if you are running 2,000 of tasks, after a bit you will have 2,000 of queue on RabbitMQ, and each queue is a airborne process. And 2 weeks ago, our broker go down for this reason, and then we change to MongoDB backend. Sorry, I didn't show the option.
Okay. Well, actually, we switched off the results because we don't need them. So yeah. Okay, so maybe next question about memory leaks, which we also have, and with Celery, the workers are growing enormously from time to time, and yeah. Well, it's like it seems like some random points. So maybe you have any like hints where to look at.
We had this problem before, but because we are using a lot of old libraries and writing frameworks,
Okay.
a lot of shitty code.
Okay.
Of course, the boss say, come on, we have to go online, and we don't have the time to rewrite everything. Then we are using this option, and until now, we don't have any problem of memory leaks on water. But I think that can also depend on some single factors.
Mm-hmm.
As you know, there is no limit to the shit that can happen on a task.
Yeah. Is there a setting that you can set up to like a threshold and say, hey, if this task exceeds, I don't know, some memory usage or time, just please notify me?
I think there is no already done.
Okay. Okay. Okay.
Anyway, it's part of the common stuff that you can use for. Yeah, it's quite strange because you have to monitoring your effect of this task, such as monitoring of monitoring. That's nice. Okay. Well, sorry, it was my first time. Then I speak a bit fast. I'm so then sorry.